So in this case, we are going to consider as a continuation working with the graph of the sine. We managed to look into its basics, all right, and also the applications, which is working on amplitude, the effect of B, the effect of P, and also the effect of what? Of Q. So in this case, we are going to look into the similar graph, which is the graph of y is equal to the cos of x. That is the cosine graph. From our derivatives, it is that the derivative with respect to x of what? The sine of x gives us the cos of x. It is only that in our syllabus, we do not dwell much about the trigonometric derivatives, but as a basic for you guys, you're supposed to know that if you differentiate sine x, you obtain cos. So meaning to say, the graph of cos is simply a derivative from the graph of what? Of a sine. With the same effects just as before. Meaning to say we can have this graph of a cos written as y when we now have the effect from the cos of x. We can have this as a cos of bx plus p plus q. Just like before, amplitude concept, the b affecting the number of cycles, the p affecting our horizontal shift, vertical shift. So what these two graphs share is what? The period of these two graphs, the graph of a sine of x, if we are given the graph of y is equal to the sine of x and y is equal to the cos of x without the effects, their period will be at what? 360 degrees. They complete their cycle in what? 360 degrees. Thus, also their spacing is the same as we are to draw these two graphs. They have same spacing of 90 degrees. Just like what we had on the graph of a sine. So with this knowledge, guys, we're not going to waste time. Let us quickly have a typical example where we can consider the graph of a cos and look into its effects. Just like what we had on the graph of a sine, we are going to do the same thing for the graph of a cos. Considering that, let's take y is equal to the cos of x. This will be the graph that we are going to use to have other graphs. So for the sake of revision, I'm just going to consider the same interval just like before. From what? From 0 to 360 degrees. Okay, so with this, we can just have a table for us to properly see how this was going to happen, guys. As we consider the x values as our input, the y values, this will be our output. Just like the graph of what? Y is equal to sine x before the effects here. Same spacing as we had before of what? 90 degrees. So from 0 to 90, from 0 to 360, that is going to be 0, 90 degrees, 180, 270, 360. All right, so we are going to notice that the values are different from what we had from the graph of a sine on the output. The output values, all right? This is cos of x, meaning to say we're going to have cos of 0. This is going to give us 1. So as we can see, that's a change that we are seeing on our values at 90 degrees. This is where we are going to obtain a 0 there. At 180 degrees, All right, at 180 degrees, that's -1. At 270 degrees, that's 0 there. At 360, just like that, at 360 degrees, that's +1. So this is what we are going to have. From the interval that we are given from 0 to 360 degrees, all right, let us just consider 90 here, 180, 270, then 360. So that's going to be 1, 2, and so on and so on, all right? But in this case, we are just limited from -1 up to +1, as we can see from our table there. So the first point, that's 0 versus 1, 0 degrees versus what? Versus 1. So we are going to have 1 here. 90 versus what? Versus 0, that is in the x-axis. 180 versus -1, 180 versus -1. 270 versus 0, that is in the x-axis. 270 versus 0, we're going to have our point direct in the x-axis. Then 360 versus what? Versus 1. 360 versus 1, like this. So we were going to mark the points first, then join these two, these points that we are given. By joining these points, we're going to have a shape like this. All right, something like this. This is what you're going to have as the graph of a course, which was going to extend just like that. So as you can see, it is actually a graph of a sine that has been changed. As I said, it's a derivative of what? Of the graph of a sine. So this is y is equal to the cos of what? Of x. What is important is the shape. From 0 to 360, if we are to consider this is the first half of the graph, then we have got the second half of the graph. So that's in 360 degrees, we have got a complete cycle, which is the period of what? 360 degrees. From this graph, we can have these effects, guys, just like before, the issue of multiplying by a, multiplying by any number. Is it a negative? Is it a positive? Still one and the same. So the effect of a, just like before, guys, let's say we want to have the graph of y is equal to half of cos x. From the same interval, when there is no other effect, it is just the a, the number that is multiplying cos. That one is going to affect its maximum and minimum values. The maximum values were at 1. Okay, here we've got this one, 0 versus 1, 180 versus -1. All right. This one, it's actually a turning point, the maximum, a turning point there. What's happening from that? The domain, same as the graph of a cost, the sign that we had before. The range from -1 up to 1, same. So that is why I do not even dwell much on those range domain. It's the same as the graph of what? Of a sine. So it's the same thing. A half there is going to multiply these values. The outputs are now multiplied by a half. So where there's a 1, it's going to be a half, a 0, minus half, a 0 there, a half, 0.5. So instead of us having 0 versus 1, we are going to be having 0 versus half. So half, that's 0.5 somewhere there. This is where we're going to have our point. 90 versus 0 is going to be there. 180 is going to be versus what? Minus half, minus 0.5. 270 versus 0. 360 versus what? Versus 0.5. So the graph of y is equal to 1 over 2 cos of x, or half cos of x, is going to be like this. All right, at 90 degrees, at 180 versus minus 0, 0.5, 270 versus 0, at 360 versus 1, like that. So this is what we are going to have as y is equal to half of what? Cos of x. It has affected its maximum value. It was at 1, now it's at half. The minimum value at minus 1, now it's at what? At minus half. So the amplitude is affected. Maximum minus minimum value divided by 2. So this is the effect when you are to draw the graph. So we are going to look into questions where they actually have the sketch already for you. All you just need is to work out from that given sketch to answer the questions. So it's the same thing. All right. We also considered the effect of what? Of Q, a vertical shift where the graph can be taken up or down. It is the same thing even for the graph of cos. We can have this graph being taken up or down. All right. We can have this graph taken up or down. All right. Let's consider that effect. So we can have the effect of what? Of Q. The vertical shift going up, that's a plus, as before, going down, a negative. Remember, we referred to that. So let's say we've got y is equal to the cos of x plus 1. Y is equal to the cos of x minus 2. It is simply shifting when it is a plus 1, because the shape is not going to change, guys. It's going to be the same as it is. But only that you have taken your graph 1 unit up. So if it was at 1 originally, it's going to be at 2. So you're going to take it until it's at what? At 2, like that. So this is how our graph will be like now. All right, something like this. It was like this. So we are going to have 180, which was at -1, now at what? Now at 0. It is just taking this graph up from where it was. Taking it down again from where it was. All right, let us just consider this one. Okay, so this is it. Let me put it here. All right, so the first one, this one, it was here. 1 unit going up. So what is important are the points. At 1, it must be at 2. So you must take it up, going up to 2. This is 1 unit up. So 1 shifted, it's now at 2. 90 degrees versus 0, 1 unit going up. Minus 1 is now here. The 270, 1 unit going up. Each unit is going up. So you now have the graph of what? Y is equal to cos of x plus 1. That's the effect. The graph will be going up. A plus. A minus, the graph will be going down. So meaning to say, if we had this original function here at where it was, it is going down 2 units. So 1 will be finding this 1, minus 1 at 0, minus 2 at what? At minus 1. So you're going to find it at minus 1 there. It's going down 2 units. 1 unit going down, 2 units going down. So find our graph something like this. All right, let me do this. So our graph is going to be something like this. 2 units going down. 1 unit, 2 units going down. We are going to find it at what? At minus 1. The 0 there, 1, 2. It's now at what? At minus 2. The minimum value, which was at 180 versus -1, we are now finding it 1, 2. It's now at what? At -3. It's now at 180 degrees versus what? -3. The point of 270 versus 0, 1, 2, it is now at 270 versus -2. 360, which was at 1, 1, 2, going down, it's now at 360 versus minus 1. Y is equal to the cos of x minus 2. The graph has gone down 2 units. So that's the effect. You must be able to trace it from the original graph, from what you are given. Before you can attempt any questions, guys, can you be able to trace it? Say, this is the graph of a course. But what is happening? Another one has just been taken up. Or another one has been just been taken down. How many units going down? That's the effect of our Q. Up or down. Just like before, we saw that there is an effect which can happen on the graph, which is the effect of what? Of P, not Q. But the effect of what? Of P. All right, so let's consider the effect of what? Of P. From what we are given, that's our horizontal shift, P. Y is equal to cos of x. Then an angle is being added or subtracted direct on that x. That's the effect of what? Of P. So remember what I said before, if it is f of x plus a, in this case, we're talking about P, which is what? The angle that is being added. A, or we can have f of x minus a, plus, we are going to the left, minus to the right, horizontally. It's a horizontal shift. So if we are given, for an example, the cos of x minus 45, from this graph of y is equal to the cos of x, what happened in order for us to have this x minus 45 where there was x? We substituted x minus 45, so it means it is f of x minus 45. F of x minus a to the right. So minus 45 degrees, it means we are simply taking our graph 45 degrees to the what? To the right. The graph has to shift 45 degrees to the right. 45 degrees to the right. So meaning to say, when it is 45 degrees to the right, guys, we are simply saying what was happening at 0 degrees, it is now happening at 45. It has shifted. What was happening at 0 is now happening at 45 degrees. Remember, at 0 it was 1. So now it is 45 degrees versus what? Versus 1. What was happening at 90 degrees is now happening at 135 if we add 45. It was 90 versus 0. It's now 135 versus 0. It has moved to the right. 180 has moved to the right. It was 180 versus minus 1. If we move it to the right, it's now at 225 degrees. Versus what? Minus 1. What was happening at 270, 45 to the right, which is what? 315. It was 270 versus 0. It's now 315 versus 0. What was happening at 360 to the right, we add. That is going to be 405. But it is now out of the what? Out of the interval. But it was supposed to be 405 versus what? Versus 1. 360 versus 1. 405 versus 1. So meaning to say our graph in this case from the interval from 0 to 360. From 0 to 360, it was going to be like this. Remember, 45 is now the one that is at 1 like this. So it's supposed to be like something like this. It's only that these points are not accurately or properly distributed, but it was going to be something like this. All right, let me put this one for the original. This is our original graph. Y is equal to cos of x. This one. This is our original graph. Or let me just reduce it a little bit. All right, this one. This is our original graph. Y is equal to cos of x. This is our original graph. So for y is equal to cos of x minus 45, which is 45 degrees to the right. This is what we now have. The graph has shifted 45 degrees at 1, 135 degrees at 0, 225 at what? At minus 1. This one is now 225 degrees versus negative 1. Before it was what? 180 degrees versus negative 1. It has shifted, it has moved, shifted to the right. So up to 360, we're going to consider up to here. This one is out of the interval. But as you can see, this was supposed to be at what? At 405, but this is now out of the interval. We just take it up to 360 according to the interval from 0 to 360. This is how our graph was going to be like. But it was supposed to extend. It has shifted 45 degrees to the what? To the right. From 0 to 45, 90 to 135, 180 to 225, 270 to 315, 360 to 405. That is what is happening. That is what happened. So this is y is equal to the cos of x minus what? 45 degrees. Be able to tell this, be able to see this effect when they have drawn the graphs for you. Be able to tell that, these effects. If you are able to tell these effects, then you won't go wrong. You'll be able to answer any question. All right, let us consider the effect of B, as we also had, let me just do this. We also have the effect of B, which our graph now has a certain number of cycles that are being completed within a certain interval. Within the given interval. Remember what we had in our previous class. So that is the effect of what? Of B. Number of completed cycle. So as the period is affected, the spacing is also affected, just like what we said for the graph of a sine and a cos. It follows that the new period from the old period of 360 degrees divide by what? By B. That is the effect of what? Of B. The spacing, which is our new spacing for the graph of a sine and the graph of a cos, is going to be the same. 90 degrees over what? Over B. The original spacing that we have of 90 degrees. So that is the effect of what? Of B. We saw this from the graph of what? Of a sine. So we're not going to have much in this case. All right. Let us just consider for an example, y is equal to 3 cos x. Cos 3x. Cos 3x. From y is equal to cos of x, this one, which is its period in 360 degrees, that's a complete cycle. It means in 360 degrees, this one is going to complete 3 cycles, 3 of them. 3 cycles will be completed. We are going to have these graphs of a cos, this one, 3 of them from 0 to 360. How is that possible? The spacing is affected. The period is affected. So for y is equal to cos of 3x, its period, which is the new period, will be what? Original 360 over what? Our B, which is what? Which is 3. So it's going to complete a cycle in 120 degrees. It will be having a complete cycle in 120. So that's why in 360 there are 3. then the spacing, meaning to say our spacing will change from 90 degrees divided by what? By B, which is 3. So that's at what? 30 degrees. So this graph, we are going to space it 30 degrees from each. Remember, this is 45. These are 45, 45, 45, half of that. So meaning to say 30 might be somewhere there. So that's 30 degrees. We space it by 30. So 30 plus 30, that is what? 60 degrees. So maybe 60 degrees, somewhere there. 120, 150. From 180, we add 30. That is going to be 210. So this one is going to be too much, guys. There'll be a lot of spacing there. 240. It's only that. Okay, let's just do it. Then this is 300. 330 up to 360. So meaning to say, what was happening at 90 degrees from the original space? Remember, it was 0, 90. What was happening at 90 degrees is what we are considering at 30 degrees. So the 0 is going to be there. At 90, oh, sorry, we are on the graph of a cos, sorry. So it's starting from there, 1 there. All right. So at 90 degrees, it was 0. This is happening now at what? At 30, according to our spacing. 60 degrees, that's the second part. The second part, according to our spacing, it was at -1. So 60 is now at -1. 270 following at 0. This is now happening at what? At 90 degrees. 360 at 1, it is now happening at 120. So it's now 120 versus 1. A complete cycle is going to be completed here. Going to have a complete cycle of a cos. One graph. So it was going to continue like that. From 1 at 120, it goes back 150 versus 0, 180 versus -1, 210 versus 0 there, 240 versus 1, 240 to 270 versus 0 there, 300 versus -1, 330 versus what? Versus 0. So it was going to be like that up to 360 versus what? Up to 360 versus 1. All right. So here I need a point. Okay, let me try to change this one. All right. Let's hope it's not going to affect here. So it's 300 -1, 330 versus 0 there. 360 versus what? Versus 1. So it has these circles are going to join these points, this one to 30 degrees versus 0 there, to -1 at 60, 90 degrees at 0 there, this one to 150 at 0 to 180 -1. Yeah, just continue with that graph like that. All right, like this, 330 up to 360 like that. So these are the effects, how to affect your graph. So meaning to say, one cycle in 120 degrees, as we considered before, to say it is going to complete its cycle in what? 120. So if we check properly, this is it. From 0 to 120 degrees here, it's a complete cycle. Another one, we have got another cycle here at what? 240. Then we have got the third one, which is the last segment up to what? 360. So you can see graph of a cos, graph of a cos, graph of a cos. Three of them formed. Three of them formed from 0 to 360. This is what we have there. So you can use these guys to answer questions now. Attempt questions. Where you do not understand, let us communicate. Like I said, we are going to do question papers also. So we can also consider that. And it is very, very important that you also do join the membership so that you do not miss any of the other classes that we are going to have. We are going to consider more revisions, questions, and question papers so that you can have a basic idea of how to answer these questions. All right, you can answer any question from there. Just try by all means to do as many question papers as you can. Try as many question papers as you can. That can actually help in these revisions. So that is it till we meet again.